Hey everyone, welcome to Shah Bytes. In this video, we are going to understand hybrid push-pull feed architecture. This architecture is commonly used in social media systems where users create posts and other users see those posts in their home feed. If this video helps you, please like the video, subscribe to Shah Bytes, and follow along for more programming and development tutorials. The main challenge is this. When a user creates a post, should we immediately push that post into every follower's feed or should we fetch it later when followers open their feed? Both approaches have advantages and disadvantages. So instead of using only one approach, we use a hybrid push-pull model. This means for some users, we push posts into followers' feeds early, but for the other users, we pull their posts later during feed read time. Let's understand the full flow step by step. First, we start with the post creation flow. The user creates a post from the front end. The front end sends a post API post request to the backend. The backend first validates the request. It checks whether the post content is valid, whether the user is allowed to create the post, and whether all required fields are present. And after validation, the backend saves the post in the main database. But saving the post is not enough. Other parts of the system also need to know that a new post was created. So, in the same database transaction, the backend creates an outbox event. This is important because the post and the event must be saved together. If the post is saved but the event is not created, the feed system may never know about the new post. If the event is created but the post is not saved, workers may process an invalid event. So both are saved in the same transaction. And after that, a publisher reads the outbox table and publishes the event into a stream. Then a worker consumes that event and starts updating the feed system. This keeps post creation fast and reliable. The user does not have to wait for all followers' feeds to be updated immediately. Now let's move to the feed cache update flow. Once the worker receives the post created event, it needs to decide how this post should be delivered to followers. This is where the hybrid architecture comes in. The worker checks one important question. Is the author a hot user? A hot user means someone with a very large number of followers. For example, our celebrities, influencers, or very popular accounts. If the author is not a hot user, then the system can use fan out on write. Fan out on write means that when the author creates a post, the system immediately pushes that post into the cached feeds of the author's followers. So if the author has a normal number of followers, this is efficient. The worker updates the home feed cache for those followers. Then, when followers open their feed later, the feed is already prepared. This makes feed reading very fast. But there's a problem with hot users. If a hot user has a million of followers, pushing the new post into every follower's feed immediately becomes very expensive. One post can cause millions of cache updates that can overload the system. So, for hot users, we avoid expensive fan out. Instead of pushing their posts into every follower's feed, we mark the author for pull on the read. This means the system will not update all follower feeds immediately. The post will be fetched later when a user actually opens their home feed. So the system saves work by only processing the post for users who actually request their feed. That is the main idea of the hybrid model. Normal users use push and hot users use pull. Now let's understand the home feed read flow. When a user opens the home feed, the front end sends a GET API feed request. The backend starts by reading the user's base feed from the feed cache. This base feed contains posts that were already pushed using fan out on write. These are usually posts from normal users that the current user follows. But this cached feed may not include fresh posts from hot users. So the backend also fetches fresh slices from hot users and that this user follows. This is the pull on read part. Now the backend has two sources of feed data, one from the hot user and one from the cache, which has the normal user data. The backend then merges these feed slices together. And after merging, the system applies ranking logic. Ranking decides which posts should appear higher in the feed. This can depend on time, engagement, relationship strength, freshness, or other ranking signals. And after ranking, the backend applies key set pagination. Key set pagination helps return the next page of feed results efficiently without using slow offset based pagination. Finally, the backend returns the final feed response. The front end renders the feed for the user, so the complete architecture works like this. So, when a post is created, it is saved in the database. An outbox event is created in the same transaction. A publisher sends that event to a stream. A worker consumes that event. If the author is a normal user, the system pushes the post into followers' cached feeds. If the author is a hot user, the system skips expensive fan out and marks the post for pull on read. And when a user opens the home feed, the backend reads the cached feed, pulls fresh posts from hot users, merges everything, ranks the result, applies pagination, and returns the final feed. This is called hybrid push pull feed architecture. It gives us the best of both worlds. Push makes feed reads fast for normal users. Pull prevents the system from doing massive fan out work for hot users. Together, they make the feed system scalable, efficient, and reliable. Thank you for watching.